Hello and welcome to another session of Me Programming Daily. Today on the agenda, drakon renderer. Specifically, I'll be continuing my work on rebalancing the whole graph, starting with a very simple graph. So off camera, I prepared a bit of an update. So this is how do we describe it? It's a list of paths that depict which icon should be shifted down as a result of injecting valent points. So if we were to contrapose both rows, we would notice that first icon and first icon are equal, second icon are equal, but the third icon and third icon here, this one is 3, this one is 4. So in order to make those two rows balanced, we need to move icon number 3 down a little bit. So for now, what I've done is I'm returning a simple list of tuples, where the first element of the tuple is an icon, and the second one is a little Boolean indicator specifying whether that icon should be shifted down or not. This indicator is always true for now. This is just an experiment. So here we have all the paths represent, all the rows in the list of lists, and we can see that in the row number 3 are identified by index 2. One of those should be shifted. For now, we're not making the decision just yet. I'm just specifying true, but the plan for today is to make this true an actual correct value, whether it's true or false, by scanning the paths underneath the currently investigated column and row, and check if an icon is there or not. If there isn't, the icon should stay where it is, and if there is, and paths below the currently investigated row and column, it means that the icon should be shifted in order to give the graph some balance. All right, so without any further ado, let's dive into the code. I'm just going to check if we're in the code view. Yes. Let's just close this. Right, let's get started. So I decided to put that logic in here in the function ABC, which is called from this function balance. And function balance simply takes the list of paths and returns a list of paths supplemented with that bool I've just shown you a little minute ago. So as a first step, what I would like to change is we don't necessarily want to scan the whole list of lists. I would like to only narrow down our search to first 3 rows. And let's keep in mind that this is not a list of paths. This is a list of contraposed paths. So instead of having just 2 rows, we will have 4, because a balanced graphs would have 4 icons in our case. So we used to have a limit of maximum. Let's just check which branch I'm on. Simple diagram balanced. We used to have a limit of maximum, meaning we would go through the entire list of lists. I don't want that anymore. For troubleshooting purposes, I'm going to stop at 2. And this should produce a list of 3 lists. Where the last row has 2 entries, 3 and 4. Decorated with true. And you might ask yourself, okay, we used to have, if we contrapose these rows, we should have 1, 1, 2, 2, 3, 4, and 4, nothing. Why all of a sudden in the latest iteration we have only 1, 1, 1, 2, and 3 and 4? So I decided to save some space and computations to keep record of these icons that we're contraposing in a map, meaning we would only see unique entries here, because if our diagrams get more complicated and we'll have tens or maybe even hundreds of different rows to contrapose, checking each individual icon, even though they are not unique, could prove to be expensive. I don't want to over-optimize so early, but at the very least, the map seems to be an obvious choice. So here we are only expecting 3 rows. 1 with the true, 2 with the true, and 3, 4, both with value true, or 4, 3. The reason, perfect. The reason I want to get rid of this maximum is I realize, while thinking about the potential new code, is that fold with an artificially generated limit is probably not the best way to go, simply because the input list of lists is going to be modified as we iterate through its rows, because we'll be injecting valence points. So checking the limit up front just makes no sense. So I'm going to take it step by step and very slowly just hard code the limit and see what happens. All right, so we narrowed down the limit to just 2. So here, now we need to perform this check that determines whether an icon that we're just adding should be shifted down or not. I think I had a function that already does it. Icon present further down the path. So let's see if we can repurpose this. I think we can repurpose it as is. No, not really. Because this used to work when our list of lists depicting paths used to be transposed. Now it isn't, so we'll have to think of something else. We can still use this logic almost unmodified. But first we need a path, a list of lists. Okay. I think I was a little bit too hasty with this because we can't even apply this yet. See, what happens here is this function gets the whole map of unique icons in a given slice, and slice is a slice through all rows on a given index, so it's 3 and 4 in our case. But if we were to apply the slice to the big list of lists, we need to check what index that slice had. So I think instead of passing the slice to ABC, we are just going to give ABC the input and the column index, and it will call slice on its own. So slice returns a map, which we are not interested in yet. Column index, so let's call this a column slice, where column slice is a slice with where we give the input and the column index as arguments. Oh, and we also need to change the function signature. So this is no longer a map. It is becoming a list of lists. And the second argument of this is an int. Perfect, let's just see how it works. So we get 1 with a true, 2 with a true, 2 with the true, 4 and 4 with the true, a 3 with a true, and nothing else. Perfect. So it works as I wanted it to. Now this function here will have to get adjusted a little bit. But before we do that, let's format, because that function is getting quite long. Oh, but the format did not suggest any changes. That's good. Now, since we have the column index, we can start reasoning about columns that appear in the list of lists after the currently inspected column. So let's come up with a function. Like this, icon present further down the path, further down another path, prime. So this gets the list of lists. Let's call it just input, icon, column index. Maybe this drop would actually work. So if it does work, let's make some changes. So this is no longer a row index. Let's call it just an I. No, it wouldn't. We are very close, but it wouldn't work. So let's call this I. And here, first of all, we need to prepare paths below, something like that, which is a result of a fold applied to input. So this will be a list of lists again. So as in the single path now, we need to drop I. Let's just check the definition of drop. Drop x, and s returns the suffix of xs after the first n element. Let's check an example. 0, 1, 2, 3, 4, 5, 6. So it's indexed 0. Mm. 1, 2, 3, 4, 5, 6. After the first elements. Okay, perfect. So 1, 2, 3, 4, 5, 6, and starting at 7th element, we go forward. Okay, so I think we can do drop I input. think this deserves a function. Let's call it a split. Our paths below. Like this. So now I'm not making any changes to the existing algorithm yet. Input. But this we can reduce. No, we can't because of the input. Oh, and I also needs to be provided. Okay. So now we need to call this. And this any we can actually reuse. So paths below we call with input and I. Okay. Our target name we need to prepare. Yes, but even now we're not calling it yet. Now we will be calling it with the prime. This gets the input, the icon, and also the column index. So if everything goes well, row with index 0 and 1 will get false. And in row with index number 2, we should get a false for icon number 3 and true for icon number 4. we seem to be getting inverted results. Let's see. So these are the same, the last two, so I'm going to replace the previous one with the new one. So one is getting a true, which is incorrect. Oh, both get a false. Okay. So something is not right here. Let's verify paths below. So let's check if paths below work for index, say 0. I'm expecting the same list of lists as here, just without the first row. And yet we are getting it up, but maybe it's just two things. No, we're only printing the first path. Okay, let's take a look. So this is already incorrect. Or maybe it isn't. Let's change it to 1. Huh. So this just swapped the rows. I'm not sure if I'm understanding this. Let's check 2. Oh, I'm sorry. It should be drop I single path, not input. So in that case, if we flip these arguments around, I should be able to reduce the function to just this and run it with correct results. And now, the order of arguments will have to flip. And now, this naturally needs to be wrapped in an array. Sorry, in a list. Perfect. So this starts at 3. This should start at 2. Perfect. So now that we verified that it works, let's check the function again. So 1 gets a true. That is still incorrect. 2 gets a true, which is incorrect. 4 gets a true. 3 gets a true. That is not correct. Okay. Oh, but this is indexed from 0. Okay. So you know what? Let's see if we really need to index from 0, C style. Let's do column index. If we do from 1, if we start from 1, ABC. That's we don't use that. We don't use that. Let's see if we have a slice. Oh no, slice is used here, which means we need to start from 0. But here, need to give it a +1. I want to make the +1 as close to the slice as possible. To help the reader connect the dots, why we do a +1 and we pass the column index to slice without +1. Right. The closer this +1 is to the invocation of slice, which needs to be indexed from 0, the better. It needs to be indexed from 0. Okay, so now we see a change. 1 it gets a false. 2 should also get a false. Let's see, it does. 4 should get a true. Yes, it should be moved. And 3 should get a false. Okay, perfect. So it looks like we've got it. Let's format the code. So now, this function will need to change a little bit. We don't need ACC1. Let's call it balance row. And this most likely won't be a fold. So now just a quick glance. 1 false, 2 false, 3 4 true, 3 false. Okay, perfect. This works. So now we'll have to change the function balance. Or maybe not. Let's not change it yet. If we well, first of all, we need to change the function balance to return not a list of tuples, but a list of lists of icons again. So let's change it. And now this will have to change. I mean, we will still be calling this, but this will change. So let's do this. Case or if icon present, then else. If the icon is not present, return it as it is. But if it's not present, oops. Let's quickly go to this function to check how to construct a valence point. Okay. Got it. And then the next row will have to shift down. So this function not only will return the balanced row, but it will also have to return a modified version of the input where the shifted icons are injected as the next row. And this is where we will use the function that I wrote a little while ago called what is it called? Oh, it's not here. I put it as a comment at one of the issues. That's fine. But for now, let's see if this works. Oh, now this bracket is not needed. And so is this one. $279. Oh yeah. We no longer work with tuples. So those brackets are not needed. Okay, so what do we get? We do get a valence point. So this shouldn't change. One should still get a false. Oh, of course, it shouldn't because we removed the tuple. 2 stays, 3 should stay, and 4 should move. So this, which used to be 4, is now gone, and we have 3. Okay, perfect. So now the balance row needs to modify the input. And I'm going to get back to it after a little break. Back in a minute. I'm back after a quick break. Let's transition to the code view. I just checked the time. I wasn't aware that we're going so fast today. Well, define fast, but it's only 47 minutes in. I think we should start looking for a good point to draw the line today for the session. So before the break, I said this function should probably also return modified list of lists. And we probably should do that. I want the modified list of lists to indicate that certain icons, if they need to be pushed, are registered in the list of paths. Okay. So how do we do this to keep this maintainable? Let's go back to drakon renderer and to the issue. Where I pasted the simple function that injects valent points. Is it in the closed issue? Isn't this? Yes. So, okay. So now I'm thinking that if this function balance row is supposed to return a single row, maybe we kill two birds with one stone and we do not balance individual rows. We just check what kind of icon needs to be inserted and where, and we just reuse this function. Insert at. Because if we do insert, we can just return the list of lists and not the modified row and the list of lists. It's just a little bit too complicated. So let's do this. Let's bring this function from a comment. We'll wrap it up for this session. And in the next session, I'll try to figure out how to not do the balance row, but instead to rename it to something else and return a modified list of balanced paths. And that way we'll get rid of this fold. Okay, I think that's a good idea. So Thank you all very much for your attention today. Thanks for sticking with me, and I hope to see you next time.